The goal of this procedure is to non-invasively image multiple fluid phases in the pore space of rock at realistic conditions of temperature and pressure, similar to those occurring in subsurface reservoirs and aquifers. This is accomplished by first assembling the core assembly carefully and placing this within a high-pressure, high-temperature core holder. The second step is to attach the core holder to the high-pressure, high-temperature control pumps and reactor using flexible PEEK tubing. Next, the pressure and temperature in the system are raised to that of the representative subsurface conditions, and fluids are equilibrated and injected into the pore space of the rock. Ultimately, reservoir condition micro-CT imaging is used to show both the amount and the distribution of carbon dioxide held in place as a trapped residual phase after brine injection.
This method can help answer key questions in the field of multiphase flow in porous media, such as determination of residual saturation for capillary trapping and wettability and contact angle measurement. Although this method can provide insights into supercritical CO2 brine rock systems with application to carbon capture and storage, it can also be used for hydrocarbon brine rock systems for studying phenomena related to enhanced oil recovery and unconventional resources.
Visual demonstration of this method is critical, as the sample preparation and core assembly steps are difficult to learn. This is because the relationship between the core assembly, the core, the confining sleeve and the multiple aluminium wraps is complicated.